Hello students, in the previous chapter we have studied about matrices and algebra of matrices. We have also learned that a system of algebraic equations can be expressed in the form of matrices. A system of linear equations like a1x plus b1y is equal to c1, a2x plus b2y is equal to c2 can be represented as a1 b1 a2 b2 into xy is equal to c1 c2. Now, this system of equations has a unique solution or not is determined by the number a1 b2 minus a2 b1. Recall that if a1 upon a2 is not equal to b1 upon b2 or a1 b2 minus a2 b1 is not equal to 0, then the system of linear equations has a unique solution. The number a1 b2 minus a2 b1 which determines uniqueness of solution is associated with the matrix A, a1 b1 a2 b2 and is called the determinant of A. Determinants have wide applications in engineering, science, economics, social science, etc. In this chapter, we shall study determinants up to order 3 only with real entries. Students, we will also study various properties of determinants, minors, cofactors and applications of determinants in finding the area of a triangle, adjoint and inverse of a square matrix, consistency and inconsistency, system of linear equations and solution of linear equations in 2 or 3 variables using inverse of a matrix. To every square matrix A of order n, we can associate a number real or complex called determinant of the square matrix A, where Aij is equal to ijth element of A. This may be thought of as a function which associates each square matrix with a unique number, may be real or complex. So, what is a determinant? Every square matrix can be associated to an expression or a number which is known as its determinant. Determinant of square matrix A is a11, a12, a21, a22 is given by determinant A is equal to a11, a12, a21, a22 is equal to a11, a22 minus a12 into a21. Here are some important points you must remember. First, for matrix A, determinant A is read as determinant of A and not modulus of A. Second, only square matrices have determinants. Now, let us look at determinants of a matrix of order 1. Let A be a matrix of order 1, then determinant of A is defined to be equal to A. Determinant of a matrix of order 2, let A be equal to A11, A12, A21, A22 be a matrix of order 2 by 2, then the determinant of A is defined as determinant of A is equal to delta is equal to A11, A12, A21, A22, that can be simplified as A11 into A22 minus A21 into A12. Now, let us take up some examples to understand how do we evaluate determinants. First, evaluate determinant 2, 4 minus 1, 2. Here we have 2, 4 minus 1, 2 is equal to 2 into 2 minus 4 into minus 1. This on simplification gives us 4 plus 4, that is equal to 8. Similarly, another question, evaluate determinant x, x plus 1, x minus 1, x. We are multiplying x into x minus x plus 1 into x minus 1. On simplification, we get x square minus within brackets x square minus 1. You know, we have used an identity here, a plus b into a minus b gives a square minus b square. Now, on opening the brackets, we get x square minus x square plus 1. This gives us answer 1. Now, let us look at the expansion of a determinant of order 3 by 3. Determinant of a matrix of order 3 can be determined by expressing it in terms of second order determinants. There are 6 ways of expanding a determinant of order 3 corresponding to each of 3 rows R1, R2 and R3 and 3 columns C1, C2 and C3. Determinant of a matrix A of order 3 by 3 can be given by determinant A is equal to A1, B1, C1 as first row, A2, B2, C2 as second row, A3, B3, C3 as third row. On expanding, A1 into B2, C2, B3, C3 minus B1 into A2, C2, A3, C3 plus C1 into A2, B2, A3, B3. This is known as the expansion of determinant A along first row. Now, students, look at the screen for an example. Evaluate the determinant 1, 2, 4, minus 1, 3, 0, 4, 1, 0. For the solution, note that in the third column, 2 entries are 0. So, expanding along C3, we get determinant as 4 into determinant minus 1, 3, 4, 1 minus 0 into determinant 1, 2, 4, 1 plus 0 into determinant 1, 2, minus 1, 3. This on simplification gives 4 into minus 1 minus 12 minus 0 plus 0, that is 4 into minus 13, and thus answer is minus 52. Here are some important remarks to be made. First, for easier calculations, we shall expand the determinant along the row or column which contains maximum number of zeros. Second, while expanding, instead of multiplying by minus 1 raised to I plus j, we can multiply it by plus 1 or minus 1 according as I plus j is even or odd. Let A be a matrix 2, 2, 4, 0 and B be another matrix 1, 1, 2, 0, then it is easy to verify that matrix A is equal to 2 into matrix B. Also, determinant A is equal to 0 minus 8, that is equal to minus 8, and determinant B is equal to 0 minus 2, that is minus 2. Observe that determinant A is equal to 4 into minus 2, that is equal to 2 square into determinant B, or determinant A is equal to 2 to the power n into determinant B, where n is equal to 2 is the order of square matrices A and B. In general, if A is equal to k into B, where A and B are square matrices of order n, then determinant of A is equal to k to the power n into determinant B, where n is equal to 1, 2, 3. Now, let us solve one question. if A is a matrix of order 3 by 3, then find the value of determinant 3A. For the solution, since A is a square matrix of order 3, therefore, we have determinant 3A is equal to 3 cube into determinant A, that is equal to 27 into determinant A. So, students, let us verify one important result using this example. If matrix A is equal to 1 0 1, 0 1 2, 0 0 4, then show that determinant 3A is equal to 27 into determinant A. For the solution, let A be a matrix 1 0 1, 0 1 2, 0 0 4. By multiplying it by 3, we get 3A is equal to 3 0 3, 0 3 6, 0 0 12. Therefore, determinant 3A becomes 3 0 3, 0 3 6, 0 0 12. Now, expanding it along C1, we get determinant 3A is equal to 3 into determinant 3 6, 0 12 minus 0 plus 0, that is equal to 3 into 12 3s are 36 minus 6 into 0 is 0. So, answer is 108. Therefore, determinant of 3A is equal to 108. Now, let us check the right hand side. We have determinant A is equal to 1 0 1, 0 1 2, 0 0 4. Now, expanding this along C1, we get determinant A is equal to 1 into determinant 1 2 0 4 minus 0 plus 0, that is 4 minus 0, that is 4. Now, multiplying it by 27, we get 27 into determinant A is equal to 27 into 4, that is 108. Obviously, LHS is equal to RHS, and hence determinant 3A is equal to 27 multiplied by determinant A. Now, let us evaluate one more determinant 3 minus 1 minus 2, 0 0 minus 1, 3 minus 5 0. Look at the solution on the screen. Let determinant be 3 minus 1 minus 2, 0 0 minus 1, 3 minus 5 0. Now, expanding this determinant along first column, that is C1, we get 3 into determinant 0 minus 1 minus 5 0 minus 0 plus 3 into minus 1 minus 2 0 minus 1. This on simplification gives 3 into 0 minus of plus 5, that is 0 minus 5 plus 3 into 1 minus 0, that is minus 15 plus 3, that gives us minus 12. So, students, today we have learnt about determinants and how to expand determinants along the rows and columns. In the next session, we shall continue with the properties of determinants and how to find area of triangle using expansion of determinants. Thank you.